Lesson 8.4, Multiplying Special Cases. The objective of this lesson is to find the square of a binomial and to find the product of a sum and difference. There are special rules you can use to simplify the square of a binomial or the product of a sum and difference. The square of a binomial. In words, this is what it means. The square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. So here are your two possible square of a binomial. The first one is a plus b quantity squared. That is equal to a squared plus 2ab plus b squared. It's the square of the first term plus twice the product of the two terms plus the square of the last term. An example is x plus 4 quantity squared. So we are going to square the first term plus 2 times the product of the two terms plus the square of the last term, which is 4, which simplifies to x squared plus 8x plus 16. The other example is a minus b squared is equal to a squared minus 2ab plus b squared. An example is x minus 3 quantity squared is equal to, you're going to square the first term minus 2 times the product of the two terms plus the square of the third term. So is equal to x squared minus 6x plus 9. In other words, if you see one parenthesis to the second power, it's either going to be a squared plus 2ab plus b squared or a squared minus 2ab plus b squared, depending on if there's a plus sign or a minus sign. The product of a sum and difference. This is the other special case. In words, the product of the sum and difference of the same two terms is the difference of their squares. An example is a plus b times a minus b is equal to a squared minus ab plus ba minus b squared, which is equal to a squared minus b squared, which is the difference of their squares. Notice that the sum of negative ab and ba is 0, leaving a squared minus b squared. Example, x plus 2 times x minus 2 is equal to x squared minus 2x plus 2x minus 4, which is equal to x squared minus 4. In other words, for the square of a binomial, you're looking for one parenthesis to the second power with a plus or minus sign. For product of a sum and difference, you're looking for two parentheses, however, with the same terms, just one has a plus sign and one has a minus sign. Problem 1, squaring a binomial. What is a simpler form of each product? X plus 8 quantity squared. So we see one parenthesis to the second power, we see the plus sign. So this is going to be a squared plus 2ab plus b squared. So square the first term, add, because there's addition here, 2 times the product of the two terms plus the square of the second term, which is 8, which simplifies to x squared plus 16x plus 64. The other example, 2m minus 3 quantity squared. Again, one parenthesis to the second power, and there's a minus sign. So there should be a minus sign here. So you're going to square the first term, subtract 2 times the product of the two terms, add the square of the third term. So when we do that, 2m to the second power is 4m squared minus 12m plus 9. Problem 4, finding the product of a sum and difference, which is the other special case. What is the simpler form of x cubed plus 8 times x cubed minus 8? Remember, product of a sum and difference, you're looking for two parentheses with the same terms in each. One has a plus sign, one has a minus sign. So the first thing you do is you write the original problem. Second step is you identify which terms correspond to a and b in the rule for the product of a sum and difference. A is your first term, b is your second term. Do not worry about plus and minus. X cubed is a and 8 is b. We're going to substitute for a and b in the rule. So the rule is a plus b times a minus b is equal to a squared minus b squared. So a is x cubed, b is 8, so x cubed squared minus 8 squared. And that simplifies to x to the 6th power minus 64. So let's do some sample problems together. What is the simpler form of each product? So the first one is n minus 7 quantity squared, and the second one is 2x plus 9 quantity squared. In both cases, we see that this is a special case. Okay, so one is n minus 7 quantity squared. So we're going to square the first term, and because I see a minus sign, I'm going to write minus 2 times the two terms plus the square of the second term. And when I do that, I'm going to have n squared minus 2 times n is 2n. 2n times 7 is 14n. Plus 7 squared is 49. That's the first answer. In the second one, we have 2x plus 9 quantity squared. So I'm going to square the first term, but the first term is 2x. I'm going to have to put that in parentheses. I see a plus sign, so I'm going to add 2 times the product of the two terms, which is 2x and 9. And then plus, and I'm going to square the second term, which is 9 squared. So 2x to the second power, you're squaring both of these terms. So that's 4x squared plus 2x times 9 is 18x. 18x times 2 is 36x plus 9 squared is 81. 81. Let's do some product of a sum and difference. So what is the simpler form of each product? So in each product you see the same terms in each parenthesis, and one has a plus and one has a minus. So all you have to do is square the first term. So x squared is x squared minus, and square the last term. 9 times 9 is 81. That one's easy. However, let's look at number 2. We have 6 plus m squared times 6 minus m squared. So we're going to square the first minus, we're going to take the second term, m squared, and we're going to square that. So 6 squared is 36 minus m squared squared is m to the 4th. And then we have 3c minus 4 times 3c plus 4. So a is 3c. We're going to square that minus 4 squared. Now again, 3c squared is not just 3c squared. It's 3 squared is 9c squared minus 16. And that's your special cases.